For in this case, if we'll take this num, right, and we'll take this as a subsequence, this is the same thing, right? We will take 1 2 3 4 5, right? These are our nothing but array elements, right? That is nums. This array is nothing but nums, right? We can say that this is the index 1 2 3 and 4. So if we'll take the this, let's suppose this is we are not deleting any element, right? As per the example definition of subsequence, we are not deleting any of this element, right? So index at 0 is 1 and 2 is 2. So 1 plus 2, if we'll do, what we'll call, we call it sum, and we'll get what? 3. We'll take the mod with k, right? Mod with k is what we have, 2. What we will get? 1. So this is nothing but a constant, right? Can we say that? So if we'll say that, if let's suppose we have given nums, we have given, and the value k we have given, right? These two things we have given, and the definition of subsequence is saying that a subsequence is valid if every pair of adjacent element in that subsequence satisfy, let's suppose, nums at sorry, give me a okay. So nums at I, some value will be there, that is, let's suppose for 0, what is we have? 1. Similarly, we'll do plus, and the nums at what? I plus 1, that is 1. Can we say that? Right? And that is nothing but our sum. This is sum. Then we are, what we have to do? We have to take the mod with the k. So what is the remainder will come? It should be constant, and it should be always equal. So we can say like this. It should be always, if this is the condition it satisfy, if this condition it satisfy, that is we have given here, right? If this condition satisfy, means this is a valid sequence, right? And we can find the length, and that length will become what? The maximum length of this valid subsequence, right? So you have to find all the subsequences, right? And you know that study I have already told you what are the subsequences are there, right? For example, if I want to find the subsequence, so subsequence with one element is 1 2 3 4 5. Can we say that we have these elements? Subsequence with two element, we can say 1 2 1 3 1 5 1 7. Can sorry, not okay. 4 we can take, 1 4, right? We can take. Similarly, we can take what? 2 3 2 4. I hope you understand, right? Like this we can take. If you want three elements, we can take what? 1 2 3, then 1 2 3 4 1 2, like that we will get all the elements. If we have four elements, we'll take 1 2 3 4, we'll take. There can be many elements, right? For three elements. Similarly for this one, for 5, for 5 we will get all the elements, and that is why this is our biggest subsequence, that having the length is maximum, so we have to return the length of maximum subsequence. I hope till now you understood everything. So as you remember study what I told you, that for example, for this example, right, you will say why this is coming 5, right? If you remember study problem, right, what I've told you, like there will be uh, a sequence. Let's suppose the patterns should be uh, for some, let's suppose this is for even, this is for even, 0 is for even, and 1 for odd, right? So all become what? When 0 0 is there, it will come even even. When 0 1 is there, odd even. When we have 1 1, both are odd. When we have, so these are the patterns we have seen, right? So in this case, what we can say that since these element, or we can say every element, every adjacent element, sum is odd, right? So for that, let's suppose all the adjacent sum is odd. Can we say that is odd, right? And so when we'll take the mod with 2, right, we will get 1. Means all are equal, and so we are getting this. I'll make you understand, don't worry, okay? So the concept is based on study itself, but little logics have changed that we will understand. So just think that for this case, let's suppose we have another example. So let's understand another example that is we have given this one. Okay. So here array we have given is 1 4 2 3 1 0, right? These are the elements given. So if we will take the element, very first element, let's suppose that is 1, right? Let's suppose, let me write in the array form. Okay. Let's suppose we have 1 4 2 3 1 and 4, and k we have given is 3. 1 4 2 3 1 4, right? 6 elements we have given, 0 1 2 3 4 and 5, right? 6 elements we have. So if we'll take the element, let's suppose 1, and we'll do plus 4, right? Nums at 0, and then nums at 0 plus 1 is 1, right? And all the element will do sum, and we'll take the mod, nothing but 3, right? What we are getting? We are getting 2. So we are getting here 2. Can we say that this is a valid for now? Okay. Then we'll take another element 2 and 4 and 2, right? Let's suppose call 4 plus 2 here. We'll take the mod with 3. 4 plus 2 is 6, and we'll take the mod 3. We'll not get any remainder. We'll get 0, right? So let's suppose this is the length. We are getting 2 here. Now it is, we are getting, let's suppose here is 0, means no remainder is there. So we'll say it's not valid, let's suppose. So let's break and we'll try the next subsequence, right? So next is what? 2 and 3. So let's suppose this time we'll take 2 plus 3, and we'll take the mod with 3. What we will get here? We'll get 5 mod 3, right? And we'll get here nothing but what we call 2 here, correct? So this is also valid. Let me remove this one so you will understand here. Okay, what we'll get here? We'll get 2 here. So this is also valid, let's suppose. Now think, if we'll take the next element is 3 and 3 and 1, right? So 3 plus 1, we'll take the mod with 3. So is it valid or not? So this will be 4, we'll get the remainder 1, right? Means this is not valid because it is less than the previous one. Let's suppose 1 plus 4, right? We'll take the mod 3 5 and mod 3, we are getting 2. So this is also valid. So we are getting validity here, not we are getting at here and here, right? Means we have tried all the chain that preserve the same sum mode, right? Can we say that? So the key idea is we have a valid subsequence that needs consecutive pair whose sum mode is same, right? And so for every index we can try to track the longest chain that ends at the index and maintains a fixed mode value, right? So what we will do, so there is, we have to find all other possible subsequence. So we have taken for now is with the 2 pairs, right? Means 1 4 4 2, like that we have taken maximum. Yes, we have taken 2, only two elements we have taken, right, for this one. Similarly we'll go for all the elements, right? Let's suppose for now, give me a second. So let's understand, if we'll take not our sequence with the 2 element, but we'll take more than 2. So there is possibility we can take 2 in the subsequence. We can take 1 element, 2 element, 3 element, 4 element, 5 element, and the 6 element itself also, right? But the condition should be satisfied, right? That we have understood. So in this case we have what? 0 to 6 0 to 5 indexes we have, right? Means total 6 element we have. So the possibility that the valid subsequences can contain the elements like this, right? So one of these, let's suppose for 4, that example we have given here is, will take the consecutive of 4. Let's suppose I'll go with 1. So what are the possibilities we can take from the subsequence that contains length 4? We'll say 1 4 2 and 3. Let's suppose this is our first subsequence, right? Can we say that? Then we can take what? 1, 4. Then we have, let's suppose we'll take, we'll discard this 2 and 3 will discard, we'll take 1, 4. 1, 4, right? There can be more possibilities, or like let's suppose we'll take 1, 4, 2, 1, and other possibility we can take what? Like this, there is many possibilities I'm saying. So let's suppose we will discard these two we are discussing on purpose. Means I don't want to keep taking all these things here. Oh, sorry. Let me clean it. Means I don't want to keep all the things at here, so it will become not looks good, right? So what I will tell you that I am going to use the same that we have given here as a sequence. So 1, 4, 1, 4, right? This we will take. Okay. So if you see, I'm picking 1, 4, 1, 4. What we are discarding? These two elements we are discarding, right? And so we are preparing this subsequence. If we'll take the subsequence, let's suppose this is I equal to 0, this is 1, 2, and 3 for the subsequence. So subsequence at 0, that let's suppose we'll call nums at I, right? Can we say that? So here we'll take so 1 plus we'll take 4, right? The sum we have to take, right? Combinations, consecutive elements we have to do the sum, and then we have to take the mod, right? With mod is what is 3, right? So what we will get here? We'll get 5, and let's suppose 2 will get here, right? Then we'll take 4 and 1, right? Can we say that? We can take 4 and 1 is what? 5. So this is 4 plus 1, we are getting mod 3, we are getting what? 2. This is 4. Similarly we'll get 1 and 4. Can we say that? This 1 plus 4 again, we are getting mod 3, we are getting 2 here. Like that, these are the combination that we are getting here. Okay, means at the place, if you remember previously, right, we have observed that these are the places that we have seen that getting the consecutive elements, right, that we have, means 1, 4, and add this 1, 4. So for the, if you discard this, so with this and this we also having the same valid subsequences, right? So if you are able to find all the subsequences, constants are same, all are, these are the constants that we are talking about, right? So these are same. So can we say that from here to here it becomes what? Your valid subsequence. And so that is why its length is how many? From 0 to 3 is length is 4, and so you are getting the length 4. Now understand what is the approach and what is the intuition, so you can implement the code. So now let's focus on understanding the intuition, right? Very first, you have given what? We have given the array. Can we say that? So this array we have given and this k we have given, right? And a subsequence is valid if the subsequence at 0, subsequence at 1, and we are taking the mod is some constant is there, right? And this constant is exactly equal to the constant that we are getting at what? This is at 1 and at 2. So subsequence at 1 and subsequence at 2 will do the sum, will take the mod, will get the same constant we will get, right? So similarly with the constant subsequence at 2 and subsequent at 3, if we'll take the sum, will take the mod, will get the same what we call constant, right? So these are the constants we have, right, when we operate on these things, right? So can we say a subsequence is valid if subsequence at 0, 1, if we'll do the mod k, will get the same value exactly as sequence at 1 and sequence at 2 is equal to, and so on till the subsequence at, let's suppose we'll call the, there will be multiple elements will be there, and so that the very last two element will be there consecutively, right? So there will be, let's suppose we'll call total length is, we have x, so this will become what? X minus 1, or you can take n, if there is n element we'll say n minus 1, and this will become n minus 2. Can we say that? So similarly here, if this is, we are talking about, it's a subsequence, right? Let's suppose this is subsequence and this is subsequence, let's suppose subsequence what we call, if this was 0, this was 1, this was what we call 1 and 2, then it was 2 and 3, right? Similarly we'll take subsequence is what? N minus 2. Can we say that? and subsequence at n minus 1, right? And you can take the subsequence, or you can say the value, the array name, the subsequence name, whatever we will take, and you will do the sum and you will take the mod k, correct? So you can see the length can be anything for this subsequence. Can we say that? And so you need to return the length of this subsequence if all are equal, if all these values are equal. This it is also coming to, right? Means yet all are equal. Can we say that? Right? And so you have to return the length of this subsequence. So we can say the core idea is to find the sequence where every adjacent pair sum has a remainder, right, is same, as a same remainder, we can say, right? When we divided by k, we can say, when we divided by k, we are getting the same remainder of of the sum pairs, you can say, adjacent pair sum, right? These are the adjacent pair, these are the adjacent pair, these are the adjacent pair, right? Can we say that? So all the adjacent, for every adjacent pair, sum has the same remainder when we divided by k, right? So instead of generating all the subsequences, right, you can, what you can do, like we can do manually, right? These we are generating manually, but we don't want to do generally. We don't want to what we call generating all the subsequences, because if you generate all the subsequences, you can see the length, right? The memory will be wasted, right? Only because of generating the subsequences, right? And that is worst here, right? Because see, 10 to the power 3, it can be worst. Let's suppose we are getting with two elements. This is our for loop will go here, then with I there is another for loop will go from the constant from I to not this I, this is for 0, 0 to 2, 0 to I, 0 to I you can take, right? Means two elements, consecutive two elements we have to take, right? In that case, whatever it will take, O of 2 to the power n it will take, right? And that we have to see that the only property we care about is subsequence is a pairwise sum modulo, and we are taking the k, right? Means we should not generate all the subsequence, we have to only care about this pairwise things, right? And we have to take the modulo, right? So pairwise sum we will take, and we will take the modulo, and for that we don't need to generate all the subsequences, right? So we can track the best way to build up the longest subsequence with the same modulo. So we can use the dynamic programming, and so that we will not do again and again the same thing. If we will calculate all the values, we will keep track, we can track the best way to build up, right? So let's think that we will use dynamic programming, okay? We will use dynamic programming, right? Let's suppose we'll talk about dp at I, you know the dp, right? We'll take the mod, right? Two things. So we'll use dp where there will be I, and this will be our mod, right? That we know, right? So and it will store what? The length of the longest valid frame, length of longest valid, what we call subsequence, right? Subsequence at we can say ending at index what we call I, right? Means we'll define the dp where I will be the index, right? So we have to find the length of the longest valid subsequence ending at I. So there will be some start, let's suppose, but at this index, what is the longest valid subsequence we have, that will keep storing here, right? So and the this is our mod is the modulo of adjacent sum, you can say, right? So we want to fill the dp table, so we can dp table for every pair j and I, right? Where j is less than I, right? We will, what we will do, we'll fill this dp table for every pair of I, j and I, where j is less than I. We'll understand what we are trying to say. Let's suppose just think that give me 1 second. Just think that we have the dp, right? And we'll take n and k, right? So we'll initialize dp n and k to 0, for all n, right? Number of elements we have given. So for all n, we'll initialize to 0. We'll say just initialize as a 0 like this. And for all mod, right? For all, you can say 0, all n, and for all mod, right? So we'll initialize as a 0. Then what we will do, we'll loop over I. We'll take the loop. Let's suppose we'll call for loop, right? We'll go from I to 0 to n. Then we'll have a nested loop inside there, right? Inside in another for loop. So this is our loop 1 and this is our loop 2. So loop 2 will start from j, right? And j will start from where? 0 to I minus 1, we can say. Okay. Let's suppose if I equal to 0, means j will go where? 0 to I minus 0 it is going, right? I minus 1. So I is already 0, we'll take minus 1. It will go minus 1, right? But these conditions you have to also satisfy that it should not go beyond the uh, boundaries, that you will understand. Okay. So each time you have to you have to compute the mode, right? What do you need to compute? So once you have I and j, give me 1 second. Once you have this I and j, give me 1 second. Okay. So what I told you, very first we'll initialize dp, this one, dp will initialize 0, means for all n and for all mod, right? Then we'll create a loop. I will start from 0 to n and j will start from 0 to I minus 1. Can we say that? Then we'll compute the mod. In this, how we are going to find? You will know that nums at j will be some value will be there plus nums at I. Can we say that? So this is our sum, and then we will take what? Mod k. Okay. So once you will get the mod, right, what you need to do, just you will find dp at I, and this is nothing but your mod. Can we say that? So each time you have to find the max, right? So you can track. How you are going to track? So this part you will, let's call it's x, right? We'll store and then we'll take dp at j, and we'll take second, let me clean here, let me expand here this side. Okay. So what we will take here, let's suppose we'll take dp at I, then we'll take mod, right? So you have all you have I and you have mod, right? What we will take, we'll say let's take max between what? This dp at I, because we have to track, right, the dp at I, and we'll take mod, and then we'll take dp at comma, this is your comma, dp at what we call j and mod plus 1. You have to increase 1. Okay. So like that you have to keep moving ahead, so you can track these values, right? So here if you are observe, right, we are updating this dp, right? dp at I and mod, right? Now you should track what? Once you will find this, you should track the max length. How you are going to find the max length, right? Let's see. You will define max length, let's call max length, right? And you need to just pass what is the max between the max length, right, and the dp at I and what you call mod, you can take plus 1, right? What is the global length? We have max length, we'll provide max length, and then we can find this one. So why we are taking dp at I mod plus 1, right? Because plus 1 we have to use for count the first element as well. We will not discard the first element. For that we have to take, so we'll return the max length. So this max length we have to return, which keeps track of the length of the longest valid subsequence. Okay, let's understand the code. So very first give me 1 second. The very first, what I told you, you have to define the dp, right? So take int let's call it like this, and we'll take dp, right? So at dp we have to define new int, and we call this as a what we call n and k, right? These two things we have to define for all n. So we have to do what? We have to find the n is nothing but nums dot length, and we say that. So now you have initially it will dp at what we call, as I told you, right, dp at n. This is our n, nothing but I, right? And this is our mod, and we say that. So this we have to find the length here, and we have to store here, right? So you can say max length. You find the max length that is ending at let's suppose I, so that uh, we can store the length here, right? You can say with mod, and we say that. Then initialize a global variable. Initialize a global, let me write like this, global max length, right? So that you can return it. So let's call it int max length, and we'll store -1, or we'll take a start 1, it's fine. Then we have to return this max length, right? Can we say that? We can store, but between that you have to write your logic here. What is the logic? Logic is, we'll go with the for loop. Int I equal to 0, very first cell we will go, right? 0 0. Okay, so for that we'll start from here. Okay, and we'll say I is less than n and I plus plus. Why we are going there, I'll show you. Wait, I have not explained in the 2D matrix, right? So it will I will show you how to do. So for int j, very first cell is in the matrix is, or you can say dp is 0 0. So we'll start from 0, and we say that. Then j should be less than what? I, right? Will not go I minus 1, right? Will not go -1, right? Will go less than I. Okay, so we'll say, let's start. We are starting from j, we are starting from 0, but j should be always less than I, otherwise the boundary condition will fail. Remember, I show you, right? Then j plus plus. So what I'm trying to do here, so I want to define a dp like this. Okay, so very first, if let's suppose if this is your I, this is your j, can we say that? Both we are starting from 0 0. So very first cell, this cell is nothing but what? This is nothing but 0 0, right? So I will start from 0 0, and j will start from 0 0. Till that will come what? I minus let's suppose we are going in n. So this is nothing but n minus 1, right? So we'll go till like this. Okay, and we'll store all the lengths here. I hope you understand, right? Now, as I told you, we find the what we call mod, right? So the mod we have to find how? We have to take the sum nums at I and j, right? You can say j first plus I, you can take ij also, nums at I, right? And then you have to take the what we call uh, divide by k, let's say remainder, right? That is k, whatever is coming, that is your mod, right? We'll take the mod. So dp at I, right? dp at I and dp at the mod. You know what we need to do? There is a math function, math.max, I think you are aware of. You will use dp at I and dp at what we call mod, right? We have to track this one, correct? Then we'll take dp at j and dp at mod, and just will take +1, correct? Means at this index, at I and at j, correct? At I and j, we have to find the length. Till I, what is the length? Then till j, what is the length, right? That we have to track, correct? Once you have the length, max length, what you need to do? You just track your global length, okay? Because as a three variable, right? You remember when we are going to find the peak values of in anything, right? What we are going to do? We are taking three variables, right? So like that, we have these variables, right? So it will give you the current max value. So we'll take math dot max and we'll get what? Max length, comma dp at I, and then mod, and then we'll do just plus one, correct? And you already have written this length. I hope you understands this code. So not a statement dp at I. So we'll see why it is giving. We have dp at mod. Okay, we have not taken math or this. Okay, there is a typo error. This one, max length. Okay, the variable length is different. Okay, fine. The code is working, right? So what you need to do? Go through the code, right? Try run yourself, right? And write the time complexity and space complexity in comment below. Okay, if you have any doubt, let me know in the comment section.